So today we're going to be doing Unit 1, Day 2. This is just a continuation from Day 1 notes. So we're going to start out talking about asymptotes. Hopefully this is a review from your Math 3 class, but if not, you can learn it now. So there's two types of asymptotes. We have horizontal asymptotes, vertical asymptotes, and then we're going to be taking a look at holes. And these are all properties that you see typically on a rational function. Just a reminder, rational function is when you have a polynomial divided by a polynomial. So this is an example of a rational function. You also find these asymptotes in other graphs, but typically rational graphs have vertical asymptotes, holes, and horizontal asymptotes. So first thing, for a vertical asymptote, this occurs when the denominator equals 0. So what we're going to do is we're going to make sure that we factor first. Okay, so for vertical asymptotes, if you can factor, you have to factor first. That's very important. So make sure that you factor first, and then that'll be where we get our cancel out any common factors, and then we're going to find the values of x that make the remaining factor 0. So, in simpler terms, we are going to factor our rational function, cancel out anything that is the same in the numerator and denominator, and then whatever is left in the denominator, we need to set those factors equal to 0, and those are your vertical asymptotes. Okay. Because a vertical asymptote is a line, you need to make sure that your answer is x equals some kind of number. Okay. So whenever you're writing your vertical asymptote, it is a line. Then make sure you're writing x equals some kind of number so that it represents a vertical line. Alright, so before we can do anything else, we're going to take this rational function and we're going to factor it. There's nothing that you can do to the numerator, so we're just going to keep that as x. In the denominator, there's a GCF of x there, so I'm going to take out x, which leaves me with x squared minus 16. Well, this is a difference of squares, so we can keep factoring the denominator. And that'll factor into x plus 4 times x minus 4. So there's my completely factored rational function. So what you want to do, if there's something you can cancel out, you're going to cancel. Well, it has this x in the numerator and denominator, so we're going to cancel that. So once you have canceled, to get the vertical asymptotes, you're going to take whatever factors are left in the denominator, and you're going to set those equal to 0. So we're going to set this x plus 4 equal to 0. So one of my vertical asymptotes will be the line x equals negative 4. And then we also have this other factor, so you have to do the same thing here. Set it equal to 0. Solve for x. So I have two vertical asymptotes in this rational function. If we were to graph it, we have negative 4, x equals negative 4, and x equals positive 4. Okay. So once again, vertical asymptotes, make sure that you factor your rational function first. Cancel anything out. You only set what's left in the denominator, not the numerator, but the denominator equal to 0, and those are your vertical asymptotes. Okay? So we're going to go ahead and look at holes next before we move on to horizontal asymptotes. So holes occur when a factor is canceled out. Holes occur when a factor is canceled out. We're going to solve the factor for x, and then to get the ordered pair, we're going to plug it back in, get the y value. So let me show you what I mean. So we're going to take the same f of x that we have here. We've already factored it. I'm just going to write this down here so you can see. We have x over x. So we canceled out the x's. Okay. So to get the holes you care about what you canceled out. So because we canceled out x, we're going to set x equal to 0. Well, there's that part. Now, a hole in a graph is an ordered pair, so we need to get the actual ordered pair of the hole. So to get the y value, and because a lot of people get confused on this, we're going to write this out, and then I'll show you. So to get the y value, of the hole, you're going to plug in the x value that we just found to what is left after the factor is canceled. Okay, so what does that mean? We know x is 0. Here's where we've done our canceling. You're going to plug it into whatever is left after you cancel. So to get the y value, we're going to plug in. There's nothing left in the numerator, so that's just going to be a 1. We canceled out that x, so that goes away. Instead of x plus 4, you're going to plug in 0 plus 4, because x was 0. And instead of x minus 4, you're going to plug in 0 minus 4. And this is to get our y value. So we're going to have 1 over 4 times negative 4 left, which is going to be 1 over negative 16. Okay, so this is the y value. So my ordered pair for my whole is going to be 0, negative 1/16. That's going to be my whole. Okay, so just to recap, for vertical asymptotes and for wholes, you have to factor your rational function before you can begin. Whatever cancels out is your whole. Whatever's left over in the denominator is going to be your vertical asymptotes. Okay, so we're going to move on to horizontal asymptotes. So horizontal asymptotes, you actually want to find before you factor. So a lot of times when I ask you to do all of these, I'll do the horizontal first. Okay, so let's make a note about that. So horizontal, we want to look at the original. And that means before you factor. Okay. Horizontal asymptotes, just like vertical asymptotes, are a line. So you should have since it's a line, it should be in the form y equals a number. Make sure you always have the y equals to represent that it's a line. So we have 3 rules here. First rule says if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. So I just think about this as having small degree over big degree. Okay. And if you have small degree over big degree, that means the horizontal asymptote is going to be y equals 0. Let me give you an example of what this means. Let's say we have the rational function f of x equals x squared plus 5 over x cubed plus 7. When we're talking about degree, we're talking about the highest exponent. So the highest exponent here is 2. And the highest exponent here is 3. So it's smaller on the top than the bottom, so small over big. So that means that this would have a horizontal asymptote at y equals 0. So anytime it's small over big, there's always a horizontal asymptote at y equals 0. Alright, next rule is if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So if it is big over small, there's no horizontal asymptote. So here's how I remember this, and one of my math teachers told me this little trick. If you have a big person sit on top of a small person, there's no person left to see. So there's no horizontal asymptote. So big on top of small, there's no horizontal asymptote left. And then that way you can just remember if it's not big over small, then it has to be 0 for small or big. Okay? So just think about, it can be like an animal. Think of a big animal sits on a little animal. There's no animal left to see. So there's no horizontal asymptote. So an example for this one, I'm just going to flip. So if we have x cubed plus 7 over x squared plus 5, so the degree is the highest exponent. So here it's 3, and in the denominator it's 2, so big over small. So there would be no horizontal asymptote for this rational function because it's big over small. Okay, and then the last scenario is if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is y equals the quotient, so you're going to set up a fraction, of the leading coefficients. So I just think about this as being same over same. And if that's the case, it's going to be y equals the coefficient over the coefficient. And I'll show you what that means. So here's an example. So let's say we have 3x squared plus 6x over 5x squared minus 9. And guys, if you notice, we don't have to factor anything to do this. You just look at the original. So in the numerator, the degree is 2, the highest exponent, and in the denominator, it's also 2. So if it's the same, what you're going to do is you're going to set up a quotient or a little fraction. You take the coefficient. So the coefficient is the number in front of the x squared. So here the 3, and then here the coefficient with the x squared is the 5. So the horizontal asymptote would be at y equals 3/5. Okay, so horizontal asymptotes you look at before you factor. There's 3 rules. Small over big is y equals 0, big over small, there's no horizontal asymptote, and if they're the same, you're going to use those coefficients.